Welcome to EDU World Space.
Let's talk about this question. We are given that a positive charge Q is located at the point x equal to 0 and y equal to minus a, and a negative charge minus Q is located at the point 0 and plus a. So show the positions of the charges in a diagram. Sure, we can do that. That's helpful for us as well. So this is the diagram, this is the coordinate plane, and we have the charges. 0 minus a is definitely over here. So this is where plus Q is located at 0 and minus a, and we have minus q located at 0 and a, so this is minus q which is located at 0 and a. The next part talks about derive an expression for the potential v at points on the x-axis as a function of the coordinate x. Take v to be 0 at infinite distance from the charges. Uh, all right, so we can do that. Let's take the point x is over here. So that's on the x-axis as a function of the x coordinates. So on the x-axis, definitely the coordinates will look like x comma 0, and we need to write an expression for the potential. So we are more interested in these directions. So that's going to be same because they are symmetric. And let's mark the distances as this one is a, this one is x. So if this one is p, then p square should be equal to a square plus x square. That's for the Pythagoras theorem. So p is going to be equal to square root of a square plus x square. So we can find out the potential at this point now. So the potential is going to be, we are working on part B now. So the potential is going to be q over kq over 4 pi epsilon naught r. So that's going to be p, and minus kq over uh, p again. So since this is symmetric and the charges are opposite, so the potential is going to be zero because of these two. That's because both are gonna be cancelled with each other because of the symmetricity in this particular figure. So any point on the x-axis, their potential is going to be zero. The next part are graph v at points on the x-axis as a function of x for the range minus 4a to 4a. So definitely even the graph will look like a straight line. So even if we have to graph it from minus 4a to 4a, and this is where minus 4a is, this is where 4a is, this is the coordinate plane, these are the axes. So if we are going to graph it, that's going to look exactly on the x-axis because the potential is nothing but zero. So the graph is going to be a straight line as good as this. And then we have, what is the answer to part B? The two charges are interchanged so that Q is on A and negative Q is on minus A. It doesn't really matter because even then that, if Q is over here and minus Q is over here, it doesn't really matter because still the distance, the figure is symmetric and the distance of the charges from this point is going to be same. So the potentials are going to cancel each other. So you're going to say that it will remain the same. Remain, it will remain the same. Thank you.